Good evening, students. Today I am going to teach you principle of superposition in electrostatics. It is a very simple law because this law states that the total effect is the sum of individual effect. The meaning: suppose there are n number of charges. There are n number of charges. Let's say this is 1, this is 2, this is third charge, fourth charge, fifth charge, and let's say this is nth charge. And you need to calculate the force on this first charge. Means other than this first charge, charge number 1, there are other n minus 1 number of charges. Each one of the charges will apply a force or will exert a force on this first charge 1. So the net force on the first charge is the sum of individual forces of 2, 3, 4, 5 and up to nth charge on the first charge. Simple. You know, force is a vector quantity. So when you have to calculate the net force on the first charge, you have to identify the force on this first charge because of each and every individual other charges. My point is, when means you are asked to calculate net force on 1. So it is written like this: F1 net. Other than this charge, the other charges are 2, 3, 4, 5 and up to n. So all the charges are applying a force on 1. So the net force I can write here. It would be F12 means force on 1 by 2 plus F13 plus F14 plus F15 plus up to F1n, as there are n number of charges. Remember one thing, while calculating the net force on the first charge or the charge given charge, you have to add these forces vectorially or by applying vector law of additions. So that is the most important part here. So let us understand this concept in a better way by giving some examples to you. Let me solve one question related to this. You will get to know it very clearly. Suppose in a simplest manner there are two charges. Let's say there are three charges, not two charges. We can say three charges. And the three charges marked as Q1, Q2 and Q3. We know there are two types of charges. So Q1, Q2, Q3 can take off any sign. So for simplicity, let us understand that Q1 is negative, Q2 is positive, Q3 is positive. Q1, Q2, Q3 are situated as shown in the diagram. Let's say the distance between these two is marked to be R12. And distance between these two means 1 and 3, it would be R13, and distance between these two is R23. Suppose you are asked to calculate the net force on this charge Q2. So you can write here, like, since you are asked to calculate the net force on Q2, I can write F2 net or Fq2 net, you can write. It's a vector So that I can write F2 net vector is equal to, means there are other charges Q1 and Q3, they are applying force on this Q2. Because of that, we can write here F21 vector plus F23 vector. As we are asked to calculate F2 net. Got? So means there are two vectors, F21 vector and F23 vector, two forces, their resultant will be F2 net. This is the first step to frame your equation. Second step is find out the direction of these two forces from the diagram, or diagrammatically try to find out the direction. See, let us find out the direction. We are dealing with, like we have to calculate the force on this second charge because of the first in our diagram. Charge 2 net force. So keep your marker here or keep your pen here. You see what is the sign of the charge? 1. As it is F21 means force on 2 by 1. I am keeping the my marker here. See the sign of the charge Q1, it is negative, Q2 is positive. So a negative charge all the time attracts a positive charge. So since it is positive charge, Q2 is positive, Q1 is negative, Q1 will try to attract Q2. If it is attracting Q2 means Q2 will go towards Q1. Means this is the direction of F21. Got? For most important thing here. Similarly, we can calculate the direction of F23. Like, again, place the marker here. See the sign of Q3. Q3 is positive, Q2 is positive. Positive repulsion. It means Q3 will repel Q2. Means if you join 2 and 3, Q2 and Q3, Q3 will repel Q2. Repel means this will be the direction in which the repulsion takes place. So this is the direction of F2, 3. So this is the direction of F21, and this is the direction of F2, 3. Now you have calculated the direction. So here I can just shift the diagram here to this side for better understanding. Like this is one force F21, this is another force F2, 3. Their tails are connected here, so I can apply your parallelogram law of vector addition like this. So this diagonal will give you the resultant force, means you are adding these two vector and getting your result is, actually your result is F2 net. So this is the application of your principle of superposition. Now this angle, the angle between these two vector means this angle, you can find out if the coordinates of these charges would have been provided, or this Q1, Q2, Q3, they are placed in a geometrical shape. Their position, if you join their position, they will take here, they are taking a triangle shape. This triangle may be an equilateral triangle, maybe a right angle triangle. So that will be simpler, easier for you to calculate this angle theta. And your final answer is to calculate the magnitude as well as direction. As you see here, we have applied parallelogram law of vector addition. So you can find out the magnitude as well as direction by using your parallelogram law of vector addition. This is the simplest case. Other cases will be there, like 4 charges are placed like this and you are asked to calculate the force on these charges. In the similar manner, you need to find out the answer, but the only difference is, let's say that is Q1, Q2, Q3, Q4. Suppose you are asked to calculate the force on this Q3 or Q4, let's say Q4. So other than Q4, there are 3 other charges are there. So means, but in this case, other than these 2 other charges are there. That's why 2 forces are there. Now, other than this Q4, Q1, Q2, Q3. So means your F4 net would be F41 vector plus F42 vector plus F43 vector. Means you have to add these 3 vector to calculate the net force on this 4th charge. So you have to follow the same procedure here. Identify the direction, and then you can add. Because this addition, it is well known to you in your standard 11th class.